Hi friends, welcome to Declutter. In today's episode, we will do a quick course on quadratic equations. While solving on various sample papers for class 10 CBSE, I realized that quadratic equations form a very important part of the papers. And the questions that come from quadratic equation majorly revolves around three aspects. One is finding the roots of the quadratic equation. Secondly, understanding if the roots are real, equal, or no real roots exist. Third is on sum and product of the roots of a quadratic equation. So without wasting much time, let us dive into quadratic equations. Firstly, let's understand what quadratic equations are. Quadratic equations are of the form ax square plus bx plus c is equal to 0. Let's understand what this means. In this case, x is a variable. It can take any value. A, B, and C belong to real numbers. Where A, B, and C can take any number real, it can be an irrational number. However, A should not be equal to 0. If A is equal to 0, as you can see, ax squared term, this will become 0. But a quadratic equation is an equation where the degree of the equation is 2. So we want to maintain the degree of the equation as 2. Hence, a cannot be 0. X is a variable. By variable, I mean x can take any values such that if x is 1, the equation becomes a plus b plus c is equal to 0. A, B, C are constants. They are fixed. Now, let us understand what we mean by roots. Other way of stating the same thing is zeros. Roots or zeros of a quadratic equation. Roots and zeros of a quadratic equation are values of x such that this equation holds true. Let's understand with an example. Let's say our quadratic equation is x square minus 4x plus 3 is equal to 0. Now, in this quadratic equation, a is equal to 1, b is equal to minus 4, c is equal to 3. These are all constants. These are all real numbers, and a is not equal to 0. Let's see what happens when I put x is equal to 3. I will get the LHS as 9 minus 12 plus 3, which is equal to 0. Satisfied? Let's put x is equal to 1. 1 minus 4 plus 3, which is equal to 0. Hence, I can say that x is equal to 1, comma 3 are roots or zeros of the quadratic equation. Fair? Now, let's come to another important aspect of the quadratic equation. Before we go into that aspect, I would like to explain you what graphical representation of the quadratic equations mean. Let's take a quadratic equation for our understanding. Let's work with x square minus 4x plus 3 because we've been working with that. Let's say y is equal to x square minus 4x plus 3. Can we plot this on the x-axis and y-axis? We know that at x is equal to 1, and at x is equal to 3, the value of y is 0 and 0. When x is equal to 2, y is equal to 4 minus 8 minus 4 plus 3 minus 1. This is another value when x is 2, y is minus 1. Alright, like this, if we go on plotting the values, what we will get is when x is 0, y is plus 3. If we go on plotting like this, what we will get is a graph like this. This graph, the red line, is called a parabola. Any point on this parabola satisfies the equation y is equal to x square minus 4x plus 3. The points where the parabola touches the x-axis are called zeros or the roots. Okay. Now let's come to the next page. Now, let us draw the graph for y is equal to minus x square plus 4x minus 3. Please see that in this case, a is equal to minus 1, b is equal to 4, and c is equal to minus 3. If again we go and plot the graph for this time our graph will look something like, this time our graph will look something like this, where this is 1, this is 3, and this is minus 3. We can verify it here by putting x is equal to 0, y is minus 3, x is equal to 1, y is 0, x is equal to 3, y is 0. This is again called a downward parabola. Again, these are called the zeros or the roots. The downward parabola is because here the value of a is negative. All right, I will quickly summarize what we have learned so far here. Quadratic equations, ax square plus bx plus c is equal to 0, a not equal to 0, a, b, c belong to R. If a is greater than 0, then we have upward parabola. If a is less than 0, we have downward parabola. A quadratic equation will always be a parabola on the x and y axis. Now, coming to the next important part of quadratic equation called roots and discriminant. Okay. Now, discriminant, let's call that as b. Some people call it as delta, is equal to b square minus 4ac. All right. Cases that exist, if delta can be equal to 0, delta can be greater than 0, delta can be less than 0. Now, if delta is equal to 0, it means the quadratic equation has two roots, but both the roots are equal. Always remember, a quadratic equation will have two roots. However, both the roots can be equal, they can be not equal, and they can not exist also. So when I say delta is equal to 0, they mean both the roots are equal, and the quadratic equation will look like this if a is greater than 0, and the equation will look something like this if a is less than 0. Okay. Now let's go to the next page to again see quadratic equation when delta is greater than 0. That means b square minus 4ac is greater than 0. In this case, the quadratic equation will look like this when a is greater than 0, or like this when a is less than 0. Please note that now we have two zeros. We have two zeros. And both the zeros are not equal. There are different zeros. All right. Last case, very simple. In this case, we have when delta is less than 0. Okay. When delta is less than 0, it's like this or like this. This is when a is less than 0. This is when a is greater than 0. Observe in this graph that the graph does not cut the x-axis. That means there is no value of x for which y is 0. There is no real value of x for which y is 0. No real roots exist. Perfect. So far, so good. Let me just quickly summarize everything on this page. Delta is equal to 0 to equal roots. Delta is less than 0. No real roots. Delta is greater than 0. 2 real roots, and delta is equal to b square minus 4ac. Again revising, ax square plus bx plus c is equal to 0 is the generic form of the quadratic equation. B is the coefficient of the x term, a is the coefficient of x square, and c is the coefficient of the constant term. All right. Now we come to the roots of a quadratic equation. Like I said, a quadratic equation has two roots. Let me first explain this with an example. Let's say that the quadratic equation is x square minus 2x plus 1 is equal to 0. Upon factorization, we see x square minus 1 the whole square is 0. X is equal to 1, comma 1. We have two roots. Both of them are equal. Now let's look at the discriminant. B square minus 4ac, which will give me 2 square minus 4 minus 2 square minus 4 into 1, which is 0. As we see, discriminant is 0. Do you remember the quadratic equation that we began the exercise with? X square minus 4x plus 3 is equal to 0. Delta is minus 4 the whole square minus 4 into 3, which will give me 16 minus 12, which is 4 greater than 0. Hence, there are two roots, 4 and 3 for this quadratic equation. All right. Now, the roots of a quadratic equation, ax square plus bx plus c is equal to 0 is given by x is equal to minus b plus or minus root over b square minus 4ac by 2a. Okay. Easier way to remember is minus b plus or minus root of delta by 2a. because we already know delta is equal to b square minus 4ac. Let's quickly use this to solve x square minus 4x plus 3 and x square minus 2x plus 1. Here a is 1, b is minus 4, and c is 3. A is 1, b is minus 2, and c is 1. Delta is 16 minus 12, which is 4. Delta is 4 minus 4, which is 0. So x is equal to minus of minus 4 plus or minus root of 4 by 2 into 1. X is equal to minus of minus 2 plus or minus root of 0 by 2 into 1. This will give me plus 4 plus or minus 2 by 2. This will give me 2 by 2, which is equal to 1, which is equal to 4 plus 2, 6 by 2, 3, or 4 minus 2, 2 by 2, 1. All right. So we get a 3 when we use 4 plus 2 by 2. We get a 1 when we use 4 minus 2 by 2. All right. So the quadratic equation that we will now look at is x square minus 3x plus 4. All right. Here a is 1, b is minus 3, and c is 4. B square minus 4ac is minus 3 the whole square minus 4 into 4 into 1, which is equal to 9 minus 16, which is equal to minus 7. As we can see, this is less than 0, right? So, no real roots exist for this equation. What we can also do with this equation is we can plot it on the x-axis and verify x square minus 3x plus 4. When x is 0, y is equal to 4. All right. When x is 1, y is equal to 1 minus 3, which is minus 2, plus 2, which is 2. When x is 2, y is equal to 4 plus 4, 8 minus 6, which is again 2. So when we plot this graph, you will see that it is something like this. First thing we observe is a is greater than 0, hence upward. Second, delta is minus 7 less than 0, hence it does not cut x-axis, no root or zeros. All right. Perfect. Now we'll go to the final part of the quadratic equation, which are the sum and product of the roots of the quadratic equation. Since we know that the roots are x is equal to minus b plus or minus root of delta by 2a, let's call one root as alpha is equal to minus b plus root delta by 2a, and beta is equal to minus b minus root delta by 2a. Alpha plus beta is sum of roots, which is minus b plus root delta minus b minus root delta by 2a, which will give me minus b by a. All right. Same way, alpha beta is product, which is equal to minus b the whole square minus root delta the whole square by 2a the whole square, which will give me b square minus b square minus 4ac by 2a, which will give me c by a. Now you will ask me how I simplified this so quickly. It's quite simple. Alpha is minus b plus root delta by 2a. Beta is minus b minus root delta by 2a. I've simply used the algebraic identity a plus b into a minus b is equal to a square minus b square, or minus b plus root delta minus b minus root delta is minus b the whole square minus root of delta the whole square. All right, perfect. How do questions come from such problems? Let's say one of the questions is ax square plus bx plus c is equal to 0 is the given quadratic equation. And they say that one of the roots of the equation, let's call it alpha, is 0. What is the other root? It's a very simple one marker question. Since we know that the sum of the roots is minus b by a, which is equal to alpha plus beta, and it is given that alpha is 0, that will give me beta is minus b by a. All right. This is one type of a question which is direct application of uh, sum and product of the roots. Let's look at another question which is an application of such a concept. Let's say that the two roots of the quadratic equation are 5 plus root 3 by 2 and 5 minus root 3 by 2. Let's say that these are the two roots of the quadratic equation. We are supposed to find what the quadratic equation is. Let's call alpha as 5 plus root 3 by 2 and beta is equal to 5 minus root 3 by 2. Alpha plus beta is equal to 5 plus root 3 plus 5 minus root 3 by 2, which is equal to 5. Alpha beta is 5 square minus root 3 square by 4, which is equal to 25 minus 3 by 4, which is equal to 11 by 2. We know alpha plus beta is equal to 5 and alpha beta is equal to 2. This is equal to minus b by a. This is equal to c by a. Assume a is equal to 1. That will give me minus b is equal to 5 or b is equal to minus 5 and c is equal to, alpha beta is equal to 11 by 2. That will give me c is equal to 11 by 2. So the quadratic equation becomes x square minus 5x plus 11 by 2 is equal to 0, which can also be written as 2x square minus 10x plus 11 is equal to 0. This is another 3-marker question that usually comes in board papers. I hope that we are clear with most of the concepts so far. Just setting the last page of this as our refresher. Ax square plus bx plus c is equal to 0 is a quadratic equation. A is not equal to 0. A, b, and c belong to real numbers. Alpha comma beta is minus b plus or minus root of b square minus 4ac by 2a. Alpha is equal to beta belong to real number if delta is equal to 0. Alpha not equal to beta belong to real number if delta is greater than 0. No real roots if delta is less than 0. delta is equal to b square minus 4ac. And alpha plus beta is minus b by a. Alpha beta is c by a. This one page is going to help you revise quadratic equations for your exam. Hope I've been clear. If you like the video, do comment, share, and subscribe. For any queries on the video, drop your queries in the comment section and I will come back to you. All right. Thank you.